Good day to you, viewers. Welcome to Biology Access. Today, we'll be looking at some work examples under pedigree analysis. If you are new to this channel, kindly subscribe and click on the notification bell so that you'll be notified anytime we post new videos. As I've said earlier, we'll be looking at work examples on pedigree analysis. Meanwhile, if you have not watched the last videos on symbols of pedigree analysis and types of pedigree analysis, kindly go back and watch those videos because the knowledge of those videos will be necessary to understand the different problems we'll be looking at under pedigree analysis. We have a question before us, and the question says, in the 18th century, a young boy suffered a skin condition that included thickening of the skin and the formation of loose spine that were periodically sloughed off. This porcupine man married and had 6 sons, of whom had the same condition. He had several daughters, all of whom were affected. What might you theorize about the location of the abdominal gene? Now we have a question before us talking about a man or a young boy that suffered from a skin condition. So before you can answer this question, you need to draw the pedigree analysis of the said problem. Now let's look at, we have the solution here with us. So let's look at the solution. From the question, a young boy suffered a skin condition. So that means that the young boy is affected with a certain skin condition. So that means that it is expressed, is affected. The skin condition is expressed. And don't forget, from the symbol of pedigree analysis, when someone is a male and that person is affected, it will be the symbol we use to represent that condition is, it will be shaded. It will be a square shape and it will be shaded. You can see it is shaded from this symbol. And this porcupine man married. He married. So this, the person is with whom is married to. From the question, it was not specified whether his wife is affected or not. So we assume that his wife is a normal female. So this porcupine man married a normal female individual, and he had 6 sons. 6 sons. 1, 2, 3, 4, 5, 6. All of whom were affected. So this man married and had 6 sons. All the sons were affected. So that means that all the sons have the same skin condition. And you can see all of them were shaded, square shaped, and they were shaded. At least they are affected. You can see one, this is the first son, the second son, the third son, the fourth, the fifth, and the sixth. He also has several daughters. None of them were affected. So that means that all the daughters are normal. So this is the solution of the question. Now from this pedigree analysis, what can you deduce from this? What can you deduce from this? The only thing you can deduce from this is that this type of abdominal gene is Y-linked. Why is it Y-linked? It is a Y-linked pedigree because it only passed from the father to the son. It passes from the father to the son. It is being transmitted from the father to the son. And it cannot be transmitted from the father to the daughter. Why? Because female individuals, they lack the Y chromosome. And this abdominal gene is only located on the Y chromosome. That's why it can only be transmitted from the father to the son and not to the daughter. Don't forget, for a male individual, it is XY, and for a female individual, it is XX. So there is no way the abnormal gene located on the Y chromosome can be transmitted to a female individual. It can only be transmitted from a father to a son because of the uniqueness of the Y chromosome involved. Because of the uniqueness of the Y chromosome involved. And another thing to note about Y-linked pedigrees, because all the male individuals, all the male sons are affected. All the male sons are affected. All of them are affected. Why is it all of them that are affected? Because all of them will definitely receive Y chromosome from their dad, and the abnormal gene is on the Y chromosome. So that's another thing. All of them are affected. It's not only affecting the father to son, but all of them are affected, and none of the female individual are affected. Now, what can we conclude from this question? Our conclusion will be that the abnormal gene is located on Y chromosome. The abnormal gene is located on Y chromosome. Why? How? The only explanation is because all the male sons are affected. All the male sons are affected because all of them receive the Y chromosome from their dads. Again, we have another pedigree chart on the board, and you may be examined, or you may be asked to indicate whether this pedigree chart is autosomal dominant, autosomal recessive, X-linked dominant, X-linked recessive, or Y-linked pedigree. Now, looking at this pedigree, it is very obvious to know that this is not a Y-linked pedigree. Y-linked pedigree can easily be excluded from this pedigree chart. Why? Because a female individual is affected with these traits. And we know that the basic rule of Y-linked pedigree is that it is only transferred, or it is only transmitted from the father to son. Why? Because the gene is always located on the Y chromosome. And we know that for male individuals, they have XY, and the male individual will be receiving the Y chromosome with the abnormal gene from his father. So since a female individual has been affected with this trait, it can't be a Y-linked pedigree. So we can easily cross out Y-linked pedigree. Can it be autosomal dominant? Looking at it, it can be autosomal dominant. Why? Because one of the rules of autosomal dominant is that unaffected parents cannot produce affected children. For autosomal dominant, if you can remember the rules, one of the rules of autosomal dominant is that unaffected parents cannot produce affected children. However, affected parents can produce unaffected children. Don't mix it up. For autosomal dominant, unaffected parents, these two are not affected, cannot produce affected children. However, affected parents can produce unaffected offspring. So this cannot be autosomal dominant. The same thing is applicable for, so we can cross out autosomal dominant, we can also cross out X-linked dominant. Why are we eliminating these two? Because according to the rule, unaffected parents cannot produce affected children. So we are now left with autosomal recessive and X-linked recessive. Autosomal recessive and X-linked recessive. Now, one of the rules of autosomal recessive is that unaffected parents can produce affected children. Unaffected parents can produce affected children. For example, if we take an example of an AS individual and also an AS individual. If they come together, there's a likelihood that they will produce an XX. So the same thing is applicable here. This one is not affected, this one is not affected, but they have an offspring that is affected. So it means that this pedigree chart may likely be autosomal recessive. Autosomal recessive. Why? Because these two parents are definitely heterozygous for that particular gene. They are heterozygous for that particular gene, meaning that they are carrier. So this pedigree analysis may likely be autosomal recessive. May likely be autosomal recessive. So we can now mark it that There's a likelihood that this is an autosomal recessive trait. Can it be X-linked recessive? Can it be X-linked recessive? It may not likely be X-linked recessive. Here is another question. Considering the following pedigree, all involving a single trait, briefly explain for each case whether any of the following mode of inheritance can be excluded. So on the board, we have three different types of pedigrees. We have A, B, C, and we have to exclude, using each of them, we have to exclude any of the four types of pedigrees: X-linked dominant, X-linked recessive, autosomal dominant, and autosomal recessive. So it means that for each of these cases, we have to exclude each of the four types of pedigree analysis. So for each of them, we are going to be analyzing your four types of pedigree analysis, whether they are, for each of them, we are going to be for each of these cases, we're going to be analyzing X-linked dominant, X-linked recessive, autosomal dominant, autosomal recessive. So the four will be, we analyze the four based on this, we analyze the four types based on this, and we analyze the four types of pedigree analysis based on this. So let's look at the first one. Let's look at A. Let's look at A. Can A be X-linked dominant? Can A be X-linked dominant? No. A cannot be X-linked dominant. Why? Because since it is a dominant trait, unaffected parents cannot produce affected children. So because none of the parents is affected, X-linked dominant can be excluded. As you can see, X-linked dominant can be excluded. Why? Because none of the parents is affected. So X-linked dominant can be excluded. Why are we excluding X-linked dominant? The reason why we are doing that is based on the rule. Why? Because non-affected parent or unaffected parent cannot produce affected children. The same thing is applicable to autosomal dominant. Autosomal dominant can also be excluded. Why are we excluding autosomal dominant? We are excluding autosomal dominant because based on the rules, non-affected parents cannot produce affected children. For autosomal dominant, we must know that it is only affected parents producing affected children. That's one. Affected parents can produce unaffected children. And the last one is that non-affected parents or unaffected parents cannot produce affected children. Please note those rules for autosomal dominant and X-linked dominant. Now let's look at X-linked recessive. X-linked recessive. Can it be X-linked recessive? Yes, it can be X-linked recessive, because one of the rules of X-linked recessive is that it can be transferred from mother to son. So this mother here must have likely be a carrier, an heterozygous of the trait, and therefore transfer it from the mother to the son. So it is likely to be X-linked recessive. The same thing is applicable for autosomal recessive. It is possible for this case to be autosomal recessive because both parents may likely be heterozygous. And also, one of the rules of autosomal recessive is that unaffected parents can produce affected children. Unaffected parents can produce affected children. Don't forget, unaffected parents can produce affected children. Don't mix it up with dominant and recessive. For dominant, let me be very clear again. For dominant, unaffected parents cannot produce affected children. For recessive, unaffected parents can produce affected children. Let me go over it again. For dominant, unaffected parents cannot produce affected children. For recessive, unaffected parents can produce affected children. So let's look at the second case. This is the second case. Can the second case be dominant? No, it is very clear. The second case cannot be dominant. Why? Because we are seeing unaffected parents producing affected children. So it can be X-linked dominant and it can be autosomal dominant. So the two of them can be excluded from this case. However, can it be autosomal recessive? Yes, it can be autosomal recessive because both parents can be heterozygous, as we have in the case of the first case. Both parents can be autosomal recessive. Both parents can be heterozygous. This can be heterozygous, this can be heterozygous. And when both of them are heterozygous, there's a likelihood that they can produce affected children. Coming to C, let's see which of the four types of pedigree analysis can be included or excluded with regards to the pedigree C. Now, let's start with X-linked dominance. Starting with X-linked dominance, X-linked dominant can be excluded. Why? Because for it to be X-linked dominant, it has to pass from the father to the daughter. It has to pass from the father to the daughter. Meaning, don't forget our formula, which is FDD. So father to daughter dominant. It is father to daughter to dominant. Because if you look at it, one of the daughter is not having the trait. So because one of the daughter is not having the trait, then it means that this cannot be X-linked dominance. It can be X-linked dominance. However, looking at X-linked recessive, there's a possibility that this trait is X-linked with recessive because the mother will have to be heterozygous. The mother will have to be heterozygous. Now, one thing is that when we come to X-linked character, it has a unique way of, there's a unique way of understanding it when we come to X-linked character, because X-linked character for male, we have XY, for female, we have XX. And X-linked character, X-linked genes is always only on the X chromosome. So meaning that for a man or for a male individual, the male individual will always carry one gene of that character, of that X trait. It will only carry one gene because it's only having one X chromosome. So for a male individual, if a male individual carry the recessive gene, it will express it. But if a male individual did not carry the recessive gene, it will be a normal individual. As you can see here, from here you can see, look at this man. This man have the recessive gene, so it's affected. This man only have the, this man lack the have the normal gene, so he's a normal male individual. So when it comes to X-linked character, there is nothing like heterozygous for male. It's either he has it or not, because he's only having one X, and that gene is only located on the X chromosome. But for the female individual, because the female individual is having two X, it can either be heterozygous, it can either be homozygous for the trait or homozygous normal for the trait. Now, with this understanding now, let's come back to whether this pedigree can be excluded for X-linked recessive. Definitely, it cannot be excluded for X-linked recessive, because for this one to be affected, it must have received the recessive gene from one X of the mother and another X from the father. So definitely, this is likely to be an X-linked recessive. This is likely to be an X-linked recessive. However, let's continue. Can we exclude autosomal dominant and autosomal recessive? No, we cannot, because if you look at it, in both cases, it affects both sexes. So because it affects both sexes, we can conclude that this may likely be an autosomal dominant and autosomal recessive. Don't forget, one of the rules of autosomal dominant and autosomal recessive that is common to both of them is that they affect both male and the female individual equally. Both male and the female individual equally. So equally. So this we have been able to solve for this each of these cases, excluding and including the four types of dominant, the four types of pedigree analysis. Sorry, the top four types of pedigree analysis, which include X-linked dominant, X-linked recessive, autosomal dominant, autosomal recessive. We have looked at the one that can be included and the one that can be excluded using the various rules that we have been taught.